Yes, I'm Brian Candler. I spend a lot of my time working with the Network Startup Resource Centre, not the National Startup Resource Centre, as it says on the display on the side. In fact, we're very much an international organisation. We spend a lot of our time working in developing countries with RENs and IXPs and campus networks and so on. So if I start talking about routing instead of routing, then I apologise. It's force of habit, and it's nothing to do with woodworking, I promise you. So I'm going to talk about IPv6-mostly networks. Now, this was relatively new to me about a year ago, so I thought it would be interesting to share with you. Some of you may know this already. I know this topic has been covered in RIPE meetings, for example, if you've been to it. But for those who haven't, I hope you find something interesting out of it. So before I talk about IPv6-mostly, I'd just like to do a recap about 464X-LAT. Now, I imagine that most of you are familiar with this, but it's just worth mentioning what this is. You'll see on the left-hand side there is an access network with a browser on it. It's a regular dual-stack network. Typically, there would be private IPv4 addresses, and there would be IPv6. And on the right-hand side, you've got another dual-stack network, this time with one or more public IPv6 addresses. And in a sort of standard network, the box in the middle would be a single box. It would be a NAT44. With 464X-LAT, you split your NAT into two. You have, on the left-hand side, a customer translator. On the right-hand side, you have a provider translator. And in the middle is just IPv6. And the IPv4 source and destination addresses that come from the left-hand side get embedded into the IPv6 addresses in the middle, and then at the end, the translator turns it back into IPv4. Now, I believe this is what Sky are going to be talking about later on, so I'm not going to go into much more detail than that, but you can see that the original design behind between 464X-LAT was so that a provider could run a V6 network. Is this going to work? Let's see. Provider could run a V6 network only in the core and still provide dual stack at the edge. And that works fine. But there is another way you can deal with this, and that's if you move the CLAT into the actual end user's device, their laptop or their phone or whatever. And if you do that, what you find is, again, your browser or whatever application is talking dual stack. It can talk to V6 destinations, it can talk to V4 destinations, but the actual network it's plugged into can be IPv6 only. And you can still access the IPv4 Internet on the right-hand side here. So it gives you a tool to move towards doing IPv6 only at the edge without losing the benefits of a dual-stack network. So what's IPv6-mostly? Well, IPv6-mostly is a couple of mechanisms that have been introduced where you can gradually sunset IPv4 by reducing the amount of IPv4 on your network until eventually you end up with an IPv6 only network, but without needing any kind of a big bang to make that transition. And there are two important mechanisms here. One is the DHCP v4 option called IPv6 only preferred. It's option 108. And the other one is a new field in router advertisements called pref64 for announcing the translator's prefix for NAT64. So with these two mechanisms, the client can come online from the network and say, I'm happy to run v6 only by requesting option 108. And if the DHCP server responds with option 108 and says, yes, you can run v6 only if you want, then the client declines to pick up a v4 address at all and is running pure v6. And if the client also gets this pref64, then it can configure its CLAT and it can access the IPv4 Internet. So you're on a pure v6 network at that point, still having full access to the v4 Internet. Effectively, your v6 network is like a super RFC 1918. You can reach the Internet through that. So why bother with this? What's the point? Well, the big driver here is from Google. Google's enterprise network has become so huge that they've simply run out of RFC 1918 address space. So from their point of view, the driver is they have to reduce their use of private addresses for IPv4. They're obviously running dual stack everywhere. Now, for everybody else, your interest might be that you don't want to run dual stack forever. right? So dual stack was great as a transition mechanism. If you've got a v4 network, you add v6 one month, you take away v4, next month you've got a pure v6 network. Great, except nobody can run like that. You can't just cut yourself off from the v4 internet. But using this approach, it allows you to reduce the number of devices that are reliant on v4, drain down your DHCP pools, and you can see who's left that requires that direct v4 dual stack. And when there's nothing left, then you've got the option to turn it off at some point in the future. So what do you need to make this stuff work? Well, you need a DHCP v4 server, which is configured to respond with option 108. And that's really easy because any DHCP server worth its salt, you just add that into the list of options that it returns. You will need a NAT64 translator, the PLAT, somewhere in your network. You will need to configure your routers to include Pref64 in their router advertisements for IPv6 so that the clients can learn where your PLAT is. And you need clients which are compatible with this way of working, which I'll talk about a little bit more. So if you've got all of that, what does it look like? Well, it's kind of magic happens. This is screenshots from my Mac, and I could say ping 8888, and I can get a response from the Google Global Echo Response server on that address. But if I run TCP dump on my Mac, I can see that the packets are actually going as IPv6 across the wire. I can go to a website that only works on IPv4, like here's BBC News, for example, which is still v4 only, and it works just fine. I can even use IPv4 literals in URLs or in other configs, and they just connect as if you were on a v4 network. It's very, very transparent. From a client's point of view, if I look at the configuration of my interface, what I see is I've picked up v6 addresses as usual. But I have this magic address 192.0.0.2 configured locally. This is the CLAT's, the client address used to talk to the CLAT. The CLAT is on 192.0.0.1. There is a /29 subnet which has been reserved for these translator addresses. I see that the CLAT itself has picked up an IPv6 address, and I see that the NAT64 prefix has been learnt from those router advertisements. Sorry, I keep doing it. So you've got this IPv4 address 192.0.0.2. That, in theory, is entirely internal to the machine and should never be seen outside. In practice, that doesn't always work, but I will come back to that. So what about this DHCP option 108? Well, the response option 108 has a parameter value, and that's the number of seconds that the client device is allowed to run single stack before it has to ask again. So if you set it to 3600, it'll run like that for an hour, and then it'll DHCP again. Now, it used to be that you needed to provide this option to enable the CLAT, but more recent clients have said, well, if I can't get a v4 address, I'm going to enable the CLAT anyway. So you don't actually need a DHCP v4 server at all to get this activated. However, the benefit of having that with option 108 is that the client is not going to keep broadcasting, constantly trying to find a DHCP v4 server that isn't there. Now, there was an older RFC for that. I've given the details there. I've never seen any client that actually implements that, but the option 108 is the one that does actually work. All right, so then you need Pref64 in your router advertisements. Lots of vendors now support this, and just a config option you can turn on, but you may find it's only in the very most recent versions of the software that you have this. At home, I use MikroTik routers because they're cheap, and in RouterOS 7.8, they added the ability to send the Pref64 announcements, but you should find on modern Cisco, Juniper, or whatever, you can do this. In Linux, there's RADVD, the router advertisement daemon, but this feature is not in the latest release, so I had to compile it from source to get this. It's working towards it. There's been a v2.20 release candidate 1 for about the last 6 months or so. They still haven't turned it into a release. But if you compile it from source, it works. However, you can't use router advertisement daemon to send these on behalf of some other router that's on the same network. So if you're going to do this, then your Linux box has to actually be the router itself. All your v6 traffic has to be routed through your Linux box. Now, the really nice thing about Pref64 as the mechanism is that it completely avoids the need for DNS6.4. So prior to this, in order to discover your translator, there was this magic DNS mechanism in RFC 7050 where you would look up the quad A record for IPv4 only.ARPA, and if you got the quad A record, you knew it had been synthesized and you could get your prefix out of that. But that's no longer needed. DNS64 itself is now not needed at all. And that's kind of good because these days you find more and more clients who are bypassing the local DNS server anyway. The browser is doing DNS over HTTPS or DNS over QUIC, so you can't really rely on DNS for that. Now, where are we then in terms of how clients that will support this? Well, the good news is macOS has excellent support. iOS, iPhones and iPads, Android all have excellent support. And that's because these mechanisms are used in a number of large mobile networks where they're v6 only to provide access to v4 Internet. So that all works really well. Windows has partial support. At the moment, it's only enabled if you're using a mobile network, directly through a mobile network card that's plugged into your laptop or whatever. But they have announced on a mailing list that they are going to extend this so you could use it on a regular Ethernet. So that should be good. Linux, unfortunately, port are non-existent. There's this shonky Perl script called clatd. If you want to install it, you then have to install other stuff to work with it, and it doesn't support Pref64 detection. So unfortunately, the state of the nation there is not great. So if you deploy this, what kind of issues are you likely to come across? Well, there's a lot of information in some of the other presentations, for example, from Jen Likova in RIPE, and you definitely want to go and watch those if you are thinking of deploying this. But the number one issue is that you're only going to find problems with your IPv6 network when you start running clients that are IPv6 only, and they have no other way to reach the internet. So if you're running dual stack, you have happy eyeballs, and if v6 breaks, basically nobody notices because everything falls over to v4. But if it's v6 only, you will notice that breakage. The kind of thing I have seen in the past is a Linux box that picks up a router advertisement, gets a default gateway, 30 minutes later it expires and it doesn't renew it. You know, you wouldn't notice that if you're dual stack. If you're on single stack, you are definitely going to notice that. There are some minor niggles. So for example, trace route to an IPv4 destination will show you stars for all of the hops. It's just not, the macOS CLAT isn't working with that at the moment. Some odd stuff with SSH, whereas if you do SSH -4 to a host name, it fails. But actually, SSH to a v4 literal address works fine, and the newer version of SSH in Homebrew also works fine. So it's just something about Apple's version of SSH. I do see this multicast, this address 192.0.0.2 leaking as a source address on multicast packets, and these are things like service discovery and multicast DNS packets that come out, which in itself isn't really a problem, but I've seen wireless controllers that don't like that. If they see the same IP address on a source packet being used by two different MAC addresses, they will kick one of the clients off and they will call it IP theft, Cisco in particular. You can disable that feature, but it's just something to be aware of. You might get caught out by it. And there are some caveats. The well-known prefix, which is the one you'll find in documentation for doing your NAT64, so 64FF9B/96, the RFC says you cannot use that with private v4 addresses to translate to or from private v4 addresses. So when I first built this in my home network, I have stuff that's only on v4 and it's only on private addresses I couldn't reach. It just turned out it was because it was using this prefix, and I changed to a different prefix and everything worked fine. So you live and learn with all of these things. Perhaps the biggest issue is you're going to need a NAT64. So you have to either configure this. If your router vendor supports it, you can enable NAT64, or you have to build it yourself using a virtual machine or something. Or you could even rent it. I did come across a company that sells NAT64 as a service across the public internet. But your translator is going to need v4 addresses on the outside, just like a NAT44. So all of this is not going to reduce your reliance on IPv4 in order to connect to the v4 internet. So the game that you are going to win is if you're looking towards replacing a dual stack with a v6 only, this gives you a path to go down that route at the edge. So I did some of this in Apricot 2024, which was in February in Bangkok, and they asked me to build a v6 only network, because traditionally the conference runs a v6 network every year. But this year we ran the v6 only network using these options. So we had a DHCP server that responded to option 108, but never gave out a v4 address. So to make that work, I actually needed a custom DHCP server. It was core DHCP. To ensure that this was a pure v6 only network using these mechanisms. And the figures there show how many people used it. It was a different SSID, so everybody had to opt in to using this by explicitly configuring their device to join this network. 142 devices joined in. 115 of those requested option 108, and they were compatible with this mechanism, which I was quite impressed by. Of the remaining 27, none of them offered the old option 116. So this is how I realized, how I discovered that it doesn't seem anybody has implemented this. And of course, those 27 devices were constantly trying to find a v4 server that would give them an IPv4 address. And so they were just trying over and over again. Okay, so if you want to know more about this, then the things I recommend you read, that first paper from a guy who works at RIPE is where I first learned about all of this stuff. And it's a very, very good summary. Some of it has changed over time. As I was saying about the requirement to use option 108 has gone. But the presentations at RIPE from Jen Linkova, who is deploying all of this stuff at Google and also is on the v6 Ops IETF list, well worth watching, especially if you are interested in what those paper cuts are that are going to bite you when you deploy this for real, because they have deployed this for real at big scale. You can, of course, just monitor your own network and see how many devices are including option 108 in their parameter request list. And if your DHCP logs don't tell you that, then even just a TCP dump will show you which devices are requesting option 108 in their DHCP discover messages. And with that, I will say that's all I wanted to talk about, but I'm very happy to attempt to answer questions from anybody who'd like to raise them. Yeah, I think you probably need to move up to the microphone there.
Are you aware of any large-scale deployments of this successfully in the wild? Are people actually doing it?
So the only large-scale deployment I'm aware of is Google, and they actually are doing it, and they're doing it very successfully. And if you look at Jen Linkova's slides, she's got graphs of the DHCP pool usage, and it's dropping by 80 to 90% when they turn this on their networks. And the last I heard, they'd got to rolling it out to like 80 or 90% of their global network, and they were just in the last stages of finishing it off. So they're very happy with it, just to get their v4 addresses back.
Hi, Tim Chown from JISC. That was a really good presentation with lots of very practical observations. It was really good, thank you. In terms of the universities we deal with, there's one, I don't think they'll mind me saying, Imperial College, who have started deploying this on their Wi-Fi. It's only initially 100 or 200 access points, but it will be on 5,000 or 6,000 access points by the end of the summer, I believe. And that's going really well. Visitors that come on via EduRoam to the Wi-Fi are just using this without knowing it and not creating any problems for the local network admin. So that's going really well in a real production environment at the university. I think the one thing I would say is you kind of blended in the v6 mostly with option 108 and that side of things with just general issues of running v6 only, which I think was important to do there. But maybe you could contribute back to if you think there are protocol gaps, you could contribute those back to the IETF, or just or put together some kind of operational experiences draft or feedback to Jen on her MOPS draft. There's a section in that on operational implications, and I think you've got some things there that aren't in that, so you've done really good work. I'll just encourage you to feed it back into places which might help make a difference, so thank you.
Thank you for those observations. I think that's important when it's being deployed on a network like Imperial College, that you don't have to run two SSIDs. You don't run one that's a dual stack and one that's a v6 only, because people are just going to join the wrong one. This is an automatic mechanism that will basically nudge people over to v6 only without them even realizing it's happening, and that's what I find is quite exciting about this. Any more questions? Okay, thanks very much.